morning students. Today we are going to discuss merge sort. It's a very important topic for NIC. Okay, you may face at least one problem from merge sort. So what is merge sort? Merge sort. In merge sort, what is the output? In merge sort, the input is an array of n element. Fine. We have n element array and the output is we need to sort the array. Fine. So before moving on the actual concept of merge sort, I'll try to discuss some basic concept which we use in our merge sort. That is, suppose we have an array A. Suppose we have an array A which is sorted in nature, that is elements are 10, 20, 30 and 40. I have one more array B which is again sorted in nature, that is 11, 21, 31 and 41. So I have two array A, array B, and both are sorted in nature. Fine. Now my task is to sort these two sorted subarray. This one is the sorted subarray, this one is the sorted subarray, and my task is to sort these two sorted subarray in a new array. Fine. So I'll take one pointer P here, I'll take one pointer Q here and try to compare first 10 and 11. Getting my point? So which one is smaller? 10. So I'll keep 10 in new array C. Increment the pointer P. Now next comparison is between 20 and 11. Which one is smaller? 11. So increment the pointer Q. Next comparison is between 20 and 21. 20 and 21. Which one is smaller? 20. So 20 here, increment the pointer P. Next comparison is between 30 and 21. So 21 is smaller, so increment the pointer Q. Next comparison is between 30 and 31 because Q point to 31. So which one is smaller? 30. So next comparison is between 40 and 31. So 31 is smaller, increment the pointer Q. Next comparison is between 40 and 41. So 40, I'll increment the pointer P, but now pointer P out of its boundary. Fine. So what we have to do, all the remaining elements we will just copy and paste here. Fine. Now tell me, I have two sorted subarrays. Having size 4, So can you tell me total number of comparisons required? 1, 2, 3, 4, 5, 6 and 7. So can I say in worst case, number of comparisons required for what? Required to sort two sorted subarray in a new array, which is going to be m plus n minus 1. And if m equals to n, I can say n plus n minus 1, which is going to be 2n minus 1 and asymptotically I can say it is order of n. So one conclusion point is, if we want to sort two sorted subarray having size n each, so total number of comparison required is m plus n minus 1, or if n is then 2n minus 1, and the running time is order of n, the time complexity is order of n. Fine. Now move on the second topic, that is suppose I have an array which is sorted in nature. Fine. I have one more array which is sorted in nature, 30, 40, 50. Fine. Now again the same procedure applies and I want to sort these two sorted subarray. So I will take a pointer P, a pointer Q. First comparison is between 10 and 30. So I'll keep 10 here, increment the pointer P. Now second comparison is between 20 and 30. I'll keep 20 here. Fine. Now if I increment the pointer P, it's out of boundary. So what I have to do? I just take copy and paste here. Fine. That is 30, 40 and 50. Now in this case, can you tell me total number of comparisons? Can I say in this case number of comparisons, here m is my 2, here m is my 3. So number of comparison is 2 only. So can I say number of comparison are minimum of m comma n, and in terms of time complexity I can say again m and n. I can say order of m or order of n, which one is minimum. Getting my point? So right now, till now, we will learn two concepts. If we have two sorted subarray, the maximum number of comparison required, is order of n in the previous case, or the running time is order of n, but the maximum number of comparison is m plus n minus 1. But again, and the minimum number of comparison required is the minimum of m comma n, and the time complex, in terms of time complexity, asymptotic time complexity, it is omega of n. Getting my point? Now we move on our actual topic, that is merge sort. In merge sort, as we already saw, the I have an input of array n size. Fine. I'll just take some elements 10, then 5, then 3, then 4, then 2, then 1, then 15 and 14. Fine. I have an array with the element 10, 5, 3, 4, 2, 1, 15 and 14. I want to sort this array. Fine. The index of these elements are 0, 1, 2, 3, 4, 5, 6 and 7. So total I have 8 elements. Now if we apply the merge sort, so how merge sort works? First of all, merge sort find the middle element. What is my middle element? That is 0 plus 7 by 2, 3.5, I can say 4. Fine. If I will take the C value. Fine. So it divide the array into two sub arrays, each having half number of elements. That is, in left hand side sub array I have the element from index 0 to 3, or if I will take floor value, so I can say 3.5 is 3, and in this side I will take 4 to 7. Getting my point? In this case I have element, again find the middle element, 0 plus 3 by 2 something. So 0 and 1 are here, 2 and 3 index element are in this sub array. Again this array is again divided into two parts, that is 4 and 5 index element are in this sub array, 6th index and 7th index element are in this array. Again I will divide because number of elements are not 1. So 0 0, 1 1, 2 2, 3 3, getting my point? Now can you just tell me what is 0 0th element? That is 10. I have an array having single element, that is 10. In this case I have an array having single element, that is 5. In this case it is 3. In this case it is 4. In this case it is 2. In this case it is 1. In this case it is 15, and in this case it is 14. Getting my point? Now what merge sort do? It just divide the arrays into sub arrays. Fine. Now comes our main topic, that is merge procedure. Merge sort call a function that is called merge procedure. And what is merge procedure? What is the task of merge procedure? It take two sorted arrays and sort these two sorted subarrays into a new array. Fine. So as we already know, this array has only single element, it is already sorted. Again this array is only single element, it is again sorted. So to sort these two sorted subarray, in a new array, how much time? Maximum number of comparison, m plus n minus 1. Here m is 1, n is 1. Fine. It means the resultant output is 5 and 10. Again we have two sorted subarrays. I want to sort these two arrays and the final output is 3 and 4. Here again I have two sorted subarray. To sort these two sorted subarray in a new array, that is 1 and 2, and in the same case I will get the output here 14 and 15. Now I have one sorted array, I have another sorted array. My task is to sort these two sorted subarray in a new array. So resultant output is 3, 4, 5 and 10. Here the output is 1, 2, 14 and 15. Now again I have one sorted subarray, I have another one sorted subarray. My task is to sort these two sorted subarray. The final output is 1, 2, 3, 4, 5, 10, 14 and 15. So this is my final output. So in this way, merge sort first divide the arrays into subarrays, then merge procedure comes into the picture, whose like functionality is to sort two sorted subarray into a single array. Fine. So if we move on the algorithm or pseudocode, what is that? We have a merge sort function. A is an array, starting index is P, last index is Q. First of all, it tries to find the middle element. What is middle element? P plus Q by 2 floor value. Fine. Now it divides the array based on the middle value. Okay. So again it will call merge sort having array A, then start with P and the last index is mid. Again it divides the subarray into right hand side subpart, that is A, starting index is mid plus 1, last index is Q. Fine. After dividing or after recursively dividing the subarrays, now at last I will call merge procedure on array A having starting index 1 is P, its last subarray index is mid, the second array starting index is mid plus 1 and its end index is Q. So this is the pseudocode for merge sort. Now my task is to find the recurrence relation or the time complexity. So can you tell me total time required for this statement is constant? Suppose I have initially an array of n element. Fine, I want to sort these n elements. Now tell me what is the size of this subarray? Can I say this subarray size is n by 2? Again this subarray size is n by 2 again. Now can you tell me what is merge procedure worst case time? As we already saw, to sort two sorted subarray in a single array, it will take m plus n minus 1 comparison whose asymptotic complexity is order of n. So my final recurrence relation is T of n. I have an array of size n and my task is to sort these subarrays. Now that is T of n by 2 one side, T of n by 2 subarray next side, and it will take order of n time. So after simplifying the whole recurrence relation, time complexity is n log n. So we can say that merge sort take order of n log n time to sort an array of size n. Getting my point? So we have one more term, that is in place. In place technique. What do we mean by in place technique? If we want to sort some array, fine, and while sorting the array, if I am taking some extra space if I am taking some auxiliary space or some extra space, then I can say my technique is not in place technique. Now tell me, is merge sort take any extra space? Yes, to sort two sorted subarray, I require one extra array of size m plus n. Fine, if my first subarray size is m, next subarray size is n, so I required a new array of size m plus n. That's why merge sort is not in place. Fine. So one more term is stable technique. Stable technique. What do you mean by stable technique? Suppose in my input I have more than one elements that are identical. Fine. So before sorting, after sorting, if the ordering of identical elements are same, then I can say my technique is stable. So we will take an example like I have input 10, 5, 2, 10b. This is my first 10, this is my second 10. After sorting, I have one type of input is 2, 5, 10a and 10b, and one more type of output is 2, 5, 10b and 10a. But as we already know, before sorting 10a comes first, then 10b. After sorting, only this type of output or this result gives me the same ordering. So I can say it is stable in nature, but it is unstable. Fine. So merge sort is what? Merge sort is stable in nature. Stable in nature. Fine. If we move on the conclusion part, of merge sort, first is time complexity. Time complexity is order of n log n. What is space complexity? Order of m plus n. Fine. Is it in place? No. It is stable? Yes. Fine. So these are the conclusion points regarding merge sort. It will take extra space. Fine, of size n. I can say m plus n. Instead of m plus n, I can say it will take n time, n space. Fine. And is it in place? No. It is stable? Yes. So this is all about merge sort. If you have any doubt, reach out to NIC YourPedia module. Thank you so much.